Hello everyone. We'll start with this particular small topic which is remaining, that is nucleophilic substitution at carbonyl carbon replacing oxygen. This particular chapter has actually the two sets of reactions. First it includes the acetal formation and second is formation of your imine or oxide, of which in our conventional lecture we all have already done with the acetal, and I hope you remember that when I talk about acetal, it is nothing but a reaction of your aldehydes and ketones to the alcohol. So when this acetal formation is taking place, you have a replacement of your oxygen of carbonyl carbon getting replaced by the something getting replaced by some another group. In fact, what I would suggest you is, before actually going through this particular video lecture, what you all can do is just go through our previous notes wherein we all have seen this particular topic, where we have written the basic comparison of nucleophilic substitution reactions of C double bond O and nucleophilic substitution reactions at carbonyl carbon replacing the oxygen, so that you will have a better understanding of this particular video that I'm going to talk about. I will not go into the details of revision part. Only reason being, it all includes, if you just recollect your acetal and hemiacetal formation, and that entire part especially includes the mechanism, and unless and until I have the writing sketch ready with me, it would be difficult for me to have the revision for you all. So I would request you to please go through that particular lecture primarily, and then followed by this particular review. So let us start with this particular reaction which is remaining, that is reaction of primary amine to form imine. Just recollect that you all have done your aldehydes and ketones reacting with all ammonia and ammonia derivatives. So if I just try to give you an example, it could be your acetone reacting with NH2 NH2 to give you the product. It could be your benzaldehyde reacting with NH2OH giving you the product. All these reactions you all have learned. When you have the product being obtained, there is one common thing that you notice. That particular common thing is, all the products that we are getting for such kind of reaction, they the product has C double bond N bond formation. And what I have told you even before is, when we have seen aldehyde and ketone as a chapter and the reactions related to aldehydes and ketone, we have just particular that this particular part we have just completed in terms of give the product or predict the product kind of particular lecture. But we have not gone into the details of mechanism for these particular reactions. So in this particular video, what we will be looking up on is how aldehydes and ketones will give you imine formation, what is imine, what is oxime, what is enamine, what is the mechanism for all these reactions, etc. Okay, so if you just go through your notebook, you will observe where we have written that table, that aldehydes and ketones reacting with ammonia and its ammonia derivative. There, one particular point you all will observe that all those reactions do take place in presence of catalyst. Similar one such reaction I have written here. This reaction includes your benzaldehyde reacting with amine, so as to give you this particular product. As you can observe that the reaction takes place in presence of catalyst, acid catalyst, and the reaction is pretty simple, that this, but as we are in the heading of, yeah, nucleophilic substitution of carbonyl carbon replacing the oxygen, so is our product what we are getting. This carbonyl oxygen is getting replaced by this particular nucleophile, and hence it gives you a nucleophilic substitution at carbonyl carbon replacing the oxygen. Needless to say that this is your electrophilic center, this is your nucleophilic center. The nucleophilic attack will take place, and some or the other way in the mechanism it involves the loss of water molecule, so you get the double bond here and the formation of water. So this particular exactly how the water is getting formed, and that entire mechanism will be. We will also see why H plus is essential in this particular type of reaction. Here on the other side, what you have is the difference difference between the structure of imine and an oxime. If you just notice this, there is just a small deviation from the structure. When I have this C double bond N further attached to the hydroxy group, this particular imine is strictly called as oxime. So I can say oxime is nothing but imine. I can say oxime is a specific form of imine wherein this R3 is nothing but your OH. So this is your very typical kind of structure which you will come across many times in your synthetic chemistry. If I consider the stability between these two, then definitely my oxime is going to be much more stable than that of my imine. The reason being, oxygen will have a lone pair of electrons, it will give this down. The nitrogen will be able to accept it. Nitrogen will shift this electron. So there is basically a scope for the resonance. So if I compare this R3 as CH3 and with the OH, definitely my oxime is always going to be more stable than that of imine. Somewhere as we will proceed, this particular concept we will highlight again. So what I'm asking you to do is just go through your notebook, find out all the reactions of aldehydes and ketones with ammonia and ammonia derivative. Just try to overlook them and just notice that everywhere you have a loss of water molecule, everywhere you have C double bond information, and all the reactions are taking place in presence of H plus. Moving ahead, our next topic is definitely to find out the mechanism for this particular reaction, how the water molecule is getting lost, and the third important point is why the reaction takes place in presence of acid catalyst. So this is one particular statement which I have captured from the Cleiden. The entire PPT is from Cleiden basically. And such kind of statements we all have even seen in periodics. Such kind of statements can be asked to you for justification. For example, imine formation requires acid catalysis. So what is expected is you give you a general reaction, you write this entire mechanism and you highlight the role of your acid. So I'm not going to simply go into the details of this mechanism. This is absolutely easy mechanism because all these mechanisms we all have done when we have done nucleophilic substitution reactions. What I will just concentrate on is I will go on explaining you this mechanism and with the help of, so I'm asking you just to concentrate on this mechanism first and then you can rewrite it on your own. This is absolutely not difficult. Okay, so starting with this, as you all know, the reaction what we are looking up is your benzaldehyde reacting with phenyl hydrazine. NH2 is hydrazine, PHNH2 is your phenyl hydrazine. So I have an electrophilic center, I have a nucleophilic center. So definitely the lone pair of electrons will attack the electrophilic center, because of which the pi electrons will shift on the oxygen, and what I am getting is the adjacent structure wherein the nitrogen has formed a bond with this particular electrophilic carbonyl carbon. Nitrogen has gained the positive charge and the oxygen has gained the negative charge. This will further will give you an hemiaminal. I'm sure this is similar to your hemiacetal, which you all have seen. So when you will go through that particular mechanism, again I'm repeating you, please go through entire hemiacetal acetal formation which we have done in the class and then only look forward for this video. So this is what it is forming is hemiaminal. How this hemiaminal is being formed is nothing but the transfer of your H from this positively charged nitrogen to the negatively charged oxygen ion, and thus it forms your hemiaminal. Once this hemiaminal is formed, this hemiaminal is protonated in the presence of acid. That is how all the reactions which you all have done so far emphasizes the presence of catalytic H plus on the arrow. When I'm carrying out the reaction in presence of acid, as we are saying imine formation requires acid catalyst, when H plus is added, that H plus will protonate this OH and will form OH2 plus. Once it forms the OH2 plus, we all have seen that this is a very good leaving group, and since this is departing, naturally in order to satisfy this particular carbon, the lone pair of electrons from the nitrogen will shift down, generating a double bond between carbon and nitrogen. Nitrogen in that process holds the positive charge which can be neutralized by shifting this pair of bonded electrons on the nitrogen, which will ultimately give you the bond. So if you you see the overall reaction we have started from here. It's your benzaldehyde reacting with phenyl hydrazine. It has given you this H2 and O. This is what, if you remember, we all have usually, I mean, this is something that is helping you to predict the product. Loss of water molecule. So this H2 and O will be lost in the form of water molecules. This space would be taken up by nitrogen attached to the phenyl. So you have C double bond in being formed. Is this structure that I'm getting in the product? Yes. And this is what is called as imine. Okay, you have C double bond N kind of structures which are called as imine. Now coming to the very important part for this particular reaction is, as I can say that when my benzaldehyde is reacting with phenyl hydrazine, imine is my final product which results because of the loss of water molecule, and hemiaminal is my reaction intermediate. Now if you observe left hand side before the hemiaminal, that is when the reaction is just commenced on the left hand side, and after hemiaminal the intermediate has formed till the product formation on your right hand side. These two, the reaction is strictly divided into the two parts. Okay, what your left hand side and right hand side tells you, the left hand side is the step which do not require the presence of acid, right? I have an electrophilic center, I have a nucleophilic center, so the reaction is a simple reaction between electrophile and nucleophile. I do not need any special H plus at this particular position. It is after when the reaction intermediate of hemiaminal has formed, I need H plus so that my OH can be converted into the better living group, and thus it can be expelled. And at this particular second half of the reaction, I strictly need H plus ion, right? So this particular reaction proceeds well in the absence of H plus. This particular half of the reaction proceeds well in the presence of H plus. So this is the reaction which is considered to be proceeding best at its best level near about its neutrality. Because if I will make it too acidic, if I will make this reaction too acidic from the beginning itself, then definitely this will hinder this particular electrophilic and nucleophilic attack. It may even protonate your NH2 unit. This is when I am having an extreme acidic condition. On extreme basic condition, the reaction may not proceed because it may try to capture the acidic proton from your helium. So, imine formation is like your biological condition reaction, which proceeds best near about its neutrality. Any of the extreme pH is not at all good for this particular reaction. The reaction proceeds within the range of its around near about its neutrality. But yes, the basic requirement is the reaction will proceed only when you have acid catalysis or the acid catalyst present in the reaction. So these two statements are very, very important from your justification point of view, from your exam point. The slide may not may not be asked exactly as such in your exam, but this is just to give you an input that there are these two graphs which have been reflected here are representing two contrasting reactions. Which, what is the contrast between the two? See, the reaction is being written on the left hand side. I have ketone reacting with amide to give me imine, and I have ester reacting with water. So it is nothing but hydrolysis of ester to give me a carboxylic acid. What we have just seen the mechanism for this, and we have said that the imine formation rate is best when you have the neutrality, but yes, the reaction proceeds in presence of acid. So as the graph indicates, near about its neutrality, pH, neutral pH, pH of 5 to 6, pH of 5 to 7, the reaction proceeds best, right? Whereas if you consider ester hydrolysis at about neutral pH, the reaction is very sluggish to follow. Whereas if you consider either the acidic pH or you consider either the basic pH, the reaction proceeds at very fast. So these are just the two contradicting or contrasting, not contradicting, but just the contrasting reactions that you have in your syllabus. You need not go into the detail, but this is just for you to show the beauty of the reaction first. The next point is imines, which we obtain, which contains C double bond N into it, which we obtain by reaction of aldehydes and ketones with the ammonia and ammonia derivative, are usually unstable and they are easily hydrolyzed in the presence of acid. So one point, if you have noticed, even in this reaction before, all these reactions or rather all the steps, if you have noticed, they all are reversible. You notice this? All these reactions are reversible, and we have written that H plus presence is must. So definitely, if I have to go from imine to my starting material, it is very much possible because all the steps are reversible, and even that will proceed best in presence of H plus. So this reaction is your mechanism of hydrolysis. I'm not going to go into the details of this. In fact, I'm asking you to do it as a self-study. We have done so many hydrolysis reactions of ester, hydrolysis reactions of acid chloride, so many hydrolysis of your acetal. Okay, so all those reactions we all have already done. This is just exactly in connection with the same. Since you are talking about the hydrolysis, what you have to have is your water as one of the reactant that you are using. So this is your product. This is reacting with the water molecule. It will have so many steps of reactions and it will ultimately give you a ketone molecule. Okay, so this is your reversible reaction. This is your hydrolysis of imine which has formed. Please try to rewrite it so that it would be easy for you to reproduce in your exam. We'll move to the next, stability of imines and oximes. This is what I was talking to you. I am sure all these reactions are familiar to you. So this is ketone is your starting material. This ketone is reacting with hydroxylamine and it is giving you NOH as a product. It is reacting with phenyl hydrazine and it is giving you this particular product. It is reacting with semi-carbazide and it is giving you semi-carbazole as your product. So everywhere what you can notice is all the three reactions are first of all falling into the category of nucleophilic substitution reactions at carbonyl carbon replacing the oxygen of it. First point. Second point, all of them have formed with the loss of water molecule because of which you are getting C double bond N. Is it present everywhere? Yes, you have C double bond N being present. And now the third part. So basically all of them are imine. Okay, then what is so special about oxime? Out of each of them, oxime is considered to be most stable. The reason being your oxime has got nitrogen attached to the oxygen. Since it is having a lone pair of electron on its head, which can be put into the resonance and thus it exhibits more stability, especially imines where you have your nitrogen atom attached to any electronegative group, they are usually stable. If you see here oximes, if you see here hydrazones, and if you see here semi-carbazole, all of them has this C double bond N further attached to electron negative unit and thus they are considered to be comparatively stable. This is in comparison with what? This is in comparison with your earlier structure where if you remember I have written here R3. Okay, so in comparison to that, each of these are comparatively stable. This is very important slide and this is something that you should know because this is something that is important the most from your exam point of view, especially in justification type of questions. Now this will require little bit of your revision of acetal formation as well. I hope you remember the reaction mechanism for acetal and hemiacetal formation. Okay, so I'm assuming that you know it and now I'm going to explain you about this. This particular slide talks about iminium ion and oxonium ion formation. Now, what is iminium ion and what is oxonium ion? As the name indicates, iminium ion is one which is involved as a reaction intermediate in the formation of imine, right? The product where you have C double bond N. Oxonium ion is reaction intermediate which is involved in your formation of your hemiacetal and acetal. So let us see these particular reaction mechanisms first and then try to deliver the analogy between them where you have similarity and where you have differences. These two reactions are nothing but the two reactions which are representing from the same topic, that is nucleophilic substitution reaction at C carbonyl carbon replacing the oxygen.